Hi, and welcome to Phase 2 of the No Black Box Machine Learning course in JavaScript. The goal here is to take the drawing recognizer we built in Phase 1 and improve its accuracy by implementing more advanced methods. Now, if you didn't complete Phase 1, you may be okay starting directly with this, especially if you already know some basic machine learning concepts. I will explain our code base briefly in the beginning, so try to understand, ask questions below or on Discord, and if all else fails, then go to Phase 1. This time we'll learn about data cleaning. It's a tedious process, but I'll teach you how to build a tool to make the job easier. Then we'll learn to visualize a confusion matrix, a special kind of table that helps us understand our model even better than the chart we built last time. It will be especially helpful when working with more than 2 dimensions. Speaking of which, so far we've only been using 2 features, but the k-nearest neighbor algorithm is not limited to that. All it needs is the way to calculate the distance between data points, and I'll teach you how to do that in 3D, 4D, 5D, any D, really. I'll show you an intuitive way to think about multidimensional spaces and distances, and we'll use up to 400 dimensions in this course. We also study another classifier, the neural network. We'll use the same code from my self-driving car course, because I want you to understand that machine learning methods are general techniques and algorithms we just apply to solve different kinds of problems. Now, this is more complex than that self-driving scenario, and our optimization strategy there wasn't really good. So I should teach you something better, like backpropagation, but I don't know how. I tried to come up with a lesson, I just can't seem to add anything to those out there. So I'll teach you how to train the network in Python, and then take the resulting model and just use it in JavaScript. So Python will do the heavy lifting, and our JavaScript app just benefits from it. Am I cheating? Maybe a bit. But I think that learning this is possible is a really important lesson here. You'll see. Finally, I'll demonstrate deep neural networks as well, so I don't get many comments about it. Now, I need to stress, this course is supposed to be a learning experience. I want you to understand how machine learning works and why we do the things we do. We use the data you helped me collect, so we have a real challenge, not some textbook dataset, and we use JavaScript because it's a high-level language where we don't need to worry about the small things, and because we can use it to build nice user interfaces that we can share without the need to download, install, and so on. I really hope you learn to build real things, not just something that reads from files and writes into the console. Another reason I use JavaScript is because it's not well known for machine learning. But many people do know JavaScript and want to learn machine learning. So if this is you, you found the perfect course. And if you don't like JavaScript, take it as a challenge and implement the same things in something you like. We don't use libraries, so it's really doable, I think. Sound good? Okay. Then if you plan to follow along, take the starting code from GitHub. It's similar to the last one from Phase 1, but a little bit different. I've added your homework submissions and made few other optimizations as well. Also, remember to get the data from this other link. Place it next to the code like this, and get ready for some spring cleaning. Get it? Well, it's spring when I'm recording this, and we're gonna start to learn about data cleaning, so... No. Gonna code, debug, and have fun. Coding with Radu, coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now. The first thing we'll check out is the drawing app we use to create new data. Here inside the web folder, and creator HTML. If you open this in the web browser, you'll see it looks quite different from before, but the functionality is still the same. It's going to ask you to enter a name here and then to draw several things. But the style is different because NinjaCoder did homework too, and I adopted his style. You can see these changes here in Style CSS, and everything I've marked as new style, starting from beginning, are things that he has added, and I commented out previous styles I've used. In case you're curious how to do different styling, I kept both here for reference. Now you'll also notice this compatibility section here at the top. And that's because in homework 1, I asked you to test the app and let me know how it went. There were some problems on iPhones, making the screen scroll when you want to draw. I got a suggestion from Meso to set touch action to none. Aaron commented that these should be set to none as well for it to work. Really not sure if these are enough because I don't have an iPhone to test, but I also got feedback from MJaque and Rick, and they said that I should go here in the Sketchpad component and add prevent default to the pointer events, which, by the way, Kelvin said I use instead of the mouse events and touch events separately. I really don't know if these comments help, because when I test on mobile, it works just fine. But please let me know if it works for you. I've added these changes on the version of the app on my website that I still use to collect data if you want to submit, and also in the recognizer that we'll build by the end of this course. Now, after you're done with the drawing and press next, you're going to get the option to save this. And it's going to create this file that contains all the information about the drawings you just made. It's a JSON file that, if I'm going to format like so, contains the information about the student, some unique identifier, and then the different drawings, the 8 different drawings, each of which are made of a collection of paths containing points. So this is the XY coordinate of the points. And this here is one path that is used to draw the car, and this is another path of the car, and another path of the car. So the car I drew had 3 different paths, and then the fish and so on. A quick note here about downloading this JSON file. Marcus suggested I set here application JSON, otherwise there could be some problems. And Godlikemouse pointed out that I don't need to add this anchor here in the body, and it still worked just fine. Now, all the data I collected from you has the same structure as this one right here, but it's inside of this data folder, and there are a bunch of them. 716 of you made drawings, so that's a total of 5,728 drawings. And we can visualize these drawings using this other app that we built. But if we open this viewer HTML in a browser, we see that nothing is there. And if we open the console, there are some errors. And that's because we need to run some scripts to get things started. These are here inside of the node folder. We open a terminal. I took Diego's advice to use the terminal from here instead of command prompt. Change the directory to be inside of this node folder, and let's make sure that we have node installed. And we do. If not, you're going to have to install it. And then you can run npm install inside of this folder, and it's going to automatically run all the scripts that we need. It now generates a dataset by running this script. And what that means is that here inside of the data, we don't have just that raw folder anymore. It created a couple of new ones. The dataset folder contains 2 subfolders. The JSON folder contains 1 file per sample. So now these paths here are for 1 drawing. The same drawing that you can actually see here in the image folder if you open 1.png. There is a car here, but because it's black and with the transparent background, doesn't look very nice. But it's okay because all our scripts have finished now, so we can investigate this data in the viewer HTML after we refresh it. You can see how Ninja Coder's style looks here as well. I like this dark mode. I think it's better on the eyes. Now, what we see here on the left are many people. The 716 who have made drawings. The drawings are here in 1 row, and if you click on one, you can see its features on the right highlighted on the chart. Now, these features, the width and the height that we extract, are the features of the bounding box. If I drag this item up here like so to see it better, this is what the width means and this is what the height means. So this car has a much larger width than the height. Seems to be about double. Now, if we scroll down here about halfway, we're going to see a new section starting called testing. And here the labels that you see written are what our machine learning system thinks that they are. The blue highlights are the correct ones, but the others are wrong. And here, if we are going to click on something, for example, this pencil, we will see a different kind of highlight here on the chart. Let me zoom in a little bit. And just to make things clear, I'm going to click on this pencil a few more times. And notice that it's not originally there. It's a new point that we've added now, and it's categorized as a pencil because its nearest neighbors, the majority of them, are pencils. Here we use 50 nearest neighbors, and I'm drawing a connection to all of them. So based on the majority, our machine learning system, the k-nearest neighbor classifier, categorizes this as a pencil. But sometimes, like this guitar, for example, seems to be a house. Let's figure out why. It's quite hard to count, but you can probably see quite many houses here in this area. So it is a house. Our accuracy is not that good at the moment, but I'm going to teach you how to double it by the end of this course. There's also this button here for opening the sketchpad. And here you can draw something live, and in real time you're going to get the classification. If you zoom out, you're going to see this drawing that we made here and all of its nearest neighbors. And in this case, the majority are pencils. But maybe if we're going to turn this into a tree, now this has changed. And the new majority seem to be trees. We've built some really nice tools, didn't we? One more thing I should remind you of is that we also have this decision boundary plot, this colored background right here. We can use this decision boundary plot more effectively if we go inside of the viewer here and pass the testing samples instead of the training samples to the chart. So now when we refresh, well, okay, things look quite different. The decision boundary is only on this side, but that's because we have this one sample here from Erminio, which I suspect actually has a really, really long width, and it was some glitch in the drawing. So for that reason, it has about 2 width instead of a maximum of 1. These are normalized. Anyway, now when we look at these testing samples here, if they lie on the same color as the decision boundary plot indicates, they are correctly classified. But if they don't, like this one right here, then it means that it's a wrong classification. So anything that looks colorful on a different background, it's a bad classification. Like this is apparently a guitar. Let's review a bit how these scripts work in the node folder. The dataset generator is creating necessary directories if they don't exist yet, and then it's generating this new form of the dataset. It's going through each of the samples one by one, and it's writing them in a new file and also generating an image for each one. This is the function from down here. Now, feature extractor is going through the samples one by one and extracting features as specified by these feature functions in use. You can find these feature functions in the common folder at the top, right here. And there are several functions defined here, but In use, we just have the width and the height functions that I mentioned previously. These two are not used at the moment. They could replace the width and the height here, but these are just much better, so we keep them for now. Now back to our feature extractor JS. After we get these functions, we call them here on the paths of every sample one by one and extract the data point. We then split in training and testing, half and half, and normalize the data to be between 0 and 1. And then we just write the output files in training and testing respectively. And there are 3 formats here: training, training JavaScript, and training CSV. And same for testing. You can find these in the data, dataset, and they're right here. The JSON files are here, and the CSV files are here. And the JavaScript files are up here in JS objects, testing, and training JS. They are the same information written in a bit different way because I want these to be accessed by our scripts here, but also by our web page. And also by the Python scripts that we have here. That's what the CSV is for. And yeah, I know Python can read JSON too. But I've seen so many people use CSVs in Python, and I think it's a common practice, and you should know about it too. So if I'm going to open here testing JSON, and I'm going to format it here, you will see first the feature names, the width and the height, and then all the samples here. Car, fish, house, tree, bicycle, guitar, pencil, clock, and then another car, fish, house, tree, and so on. All of the 2,864 samples are listed here in this long array. And the point is just the width and the height values for each of these samples. You're going to find the same information here in testing CSV, but here it's a different form. The width and the height, and then the label here. It's something you could easily paste in Excel as well. And the JavaScript file here at the top is the same as testing JSON, but with this in front of it. It's creating essentially a global variable called testing with this content here. And I'm not particularly happy about this code structure. It would have been much better to use modules here and make them read JSON. Actually, Rumah suggested I do that, and I recommend you try what he says there. The problem for me is that if I use the live server extension, for some reason everything starts lagging on my computer. I'm not sure if it's just me or for some reason the code we're writing doesn't work in general with the live server extension, but if you do, try it out. Let me know how it went. Now, going back to these node scripts, the last one is run evaluation, and it's going to use the KNN classifier here, built using the training samples, and it's going to classify the testing data and compute an accuracy. It also generates this decision boundary plot and stores it here in data models. This is where that image comes from. Now, this image is a low resolution here because when running this script, this part is quite slow. It's going to generate that color for each individual pixel. And the size of this image is 100 by 100 pixels, but that means 10,000 different pixels there to calculate. And for each pixel, you need to calculate the distances to all of the nearest neighbors. And that's a really intensive process. So if you want to set here a bigger value like 5,000, this decision boundary plot is going to look much nicer, but you're going to have to wait a few hours. But you're in luck, because if you want to see how such a decision boundary plot looks like, you can open up this resources folder, and it's this one right here, KNN 50. You can replace the one from here if you want to see it in action on the web page. and refresh. And now it's much sharper, and you can also zoom in to see how the edges look like. Now, before we get into implementing new things, I have to mention this chart right here. I've implemented a more optimized version of it. If we close these things and open the chart from the web folder, the optimization I've done is that from the chart homework. Nobody did it, and I can understand why. It's kind of challenging. But I did point out what I did here and there, and you can compare with the previous code if you're curious. Basically, if doing something like maybe updating now this point here, the one that we are drawing, I'm not redrawing everything all the time. It just updates this one drawing on an overlay canvas on top of the previous one. I did get one optimization for the scaling, which I've added here. This was suggested by Petr. And I also want to point out improvements I got to my prerequisite videos about 2D vectors and trigonometry from Cristian and George. Cristian rewrote the code in an object-oriented way and used Bootstrap, and George tells us how to make it work if you scroll with the MJaque on Apple devices. Also, one funny thing that happened is that these emojis now are different than before because I got Windows 11 on my operating system and they changed a bit. I recolored them a little bit differently here with the filters, but they would have been just fine otherwise as well. Quick mention to this Python folder here. So if I'm going to start the terminal now and go to Python folder and type Python KNN, we're going to get the accuracy here as well. But the code there is really small, like this is it. Because we use the scikit-learn library and we import the k-nearest neighbor classifier from there, read the data from our CSV files directly. And this is actually done here with the read feature file function from the functions py. And the Python is not really adding anything into this project. It's just showing you another way of doing things with libraries, which is common, I think. Now let's begin to implement a way to do data cleaning. And speaking of cleaning, I reformatted all the code to use spaces now. And we are going to be testing on a different window like this. I got a lot of bad comments saying I should use spaces. And now with this larger window here, I have room for that. Now, data cleaning means that we are going to throw out some samples which make our model bad for some reason. For example, here, this is a drawing of a guitar, but it looks like some kind of mistake. And same for this pencil here. We can also see maybe here, this one, this is not the drawing of the car. It's a drawing of a bird, I think. So small things like that are probably ruining the model in some way, I'm going to want to throw away. It's very tedious to start writing down which samples need to be removed. So I'm going to build a tool that allows me to click on the samples here and remove them. You'll see. But now the clicking is implemented already here in display.js, right here where we click on the sample container. And we should inspect the event we get when clicking here to see if we can figure out how to maybe control click on the item and do something else instead of this handle click function. So I'm going to type here EVT for event, and now I'm going to open here a curly brace and close it like this because we're going to write more things. Let's begin with the log in the console, logging this event, saving the file, and now refreshing the page, and I'm going to open the console and click on something here. And you can see now the event is printed here. If we look at the properties, we will find this control key that is set to false. And if I hold now control when I click on something and scroll down here, we will get another print of the event, but this one has control key set to true. So that's how we're going to distinguish between the two. Let's remove this line and check if the control key is on. We are going to toggle the flagged sample because I want to flag something when I click on it like that, but I also want to unflag something in case I did a mistake. I don't want to refresh the whole page if that happens. So otherwise, here we're going to say else and put this handle click in that case. Now, this functionality for toggle flagged sample will be implemented in a new file. I'm going to call this data cleaner. So let's open our viewer here and import this new file, data cleaner, and create it here inside of this JavaScript folder. Data cleaner.js. Here our flagged samples are going to go inside the list, which is empty for now, and our function for toggle flagged sample, given a sample, is going to do the following. It's going to check if the flagged samples includes the ID of the sample, and if so, we will remove it. I first get the index of this sample that we clicked on, and then I'm going to remove it by using the splice at the given index, removing one item. Now, if we clicked on something that isn't yet in the flagged samples, we just add it there using the push method, like so. And now we want to visually emphasize which items are flagged and which not. We're going to make a flagged class that is going to be added to all the flagged samples. And every time we click on something, we remove the class from everything and then add the class to those flagged samples, kind of like a refresh mechanism. So let's first remove this flagged class from all items that are flagged, like this, using a for each loop so that each item's flagged class gets removed and then re-added like so. We are going to loop through the flagged samples, get the element using getElement by ID, the sample with that ID, and add this to the class list, like so. So this should work. Only thing we need is a new class called flagged, and we're going to be adding that in styles.css, and I'm going to be doing it here at the bottom of the file. It's just going to be marking everything with a red color, and I'm using here important because I want it to be on top of the previous style. Let's save this and now refresh. And clicking things normally works as before, but control clicking gives us this flagged view. And if I click again on the item, it's going to go away. So let's start flagging here the things I pointed out previously. And I'm now going to go through all the things and mark down anything I see suspicious. And I'm done. It took much longer than I thought it will, but it's over. And I basically mark down things that are incorrect or don't look at all like what they should be. This should be a bicycle, but somebody drew a house here, so sometimes these things happen. And Pi just drew mixing things up. I think they wanted to see how the system handles those cases. But most of the data is quite good, and in total I think there is probably about maybe 200 or so flagged samples. This is a funny one. This is supposed to be a house, but many people drew a horse there instead, like Jin. And I think this has to do with psychology. And basically, house and horse are very close when you look at the letters. And I asked you to draw a house after a fish, so it's after another animal. And without a context, just being told to draw this, then you might read horse by mistake. And Jin is not the only one. There are actually quite many horses here in the database. And that's funny because it reminded me of this Mandela effect. If you don't know what it is, I'm gonna link it in the description. But basically, there are things that people remember differently than what they happened, and there are things that large groups of people remember something differently than what actually happened. And this could be one example of that. Like if we're gonna group together everybody who has drawn horses here, and we ask them what were they supposed to draw, they will definitely remember the horse being asked, but I never asked anybody to draw a horse. I asked for a house. Anyway, let's have a look at our flagged samples. So I'm going to type this in the console here. And there are, actually close to 300 of them. So 300 flagged samples. That means we have 5,445 to work with. And one thing I really need to mention here is that I actually flagged samples also in the testing set. And normally you don't do that, because testing should be as natural as possible, and we only want to do the flagging in the training data, which we use to create our models. But I did it because I don't think it's going to impact on the accuracy that much, and I think that the people who have made those drawings that are messed up on purpose will not expect the system to mess up as well. So normally that's not needed. But also because I don't want to do this again anytime soon, and if more data comes, then a lot of them are going to be flagged already. So yeah, just keep in mind that normally you don't touch the testing samples. Now, this array here is quite long, and I would like to copy it somehow. I'm just going to write here JSON stringify the flagged samples. And this is going to display all of it here as a string, like so. I'm going to copy it and go into Common and Utils, and under the flagged users, which are people that have drawn some bad stuff, I'm going to add here flagged samples. And I'm going to paste here what we got and remove the string syntax from there. And now we're going to use these flagged samples when creating the dataset to omit them from the raw data. We'll still keep them in the raw data for reference, but we won't be using them in any of our tasks. So let's go here inside of our node folder and dataset generator, and right here a line in this for loop that is going through all of the samples like so. If the sample is not flagged, So if the flagged samples doesn't include this ID that we are generating here, then we do everything for it. Write it in the new file and generate the image for it here. Like so. And now we can run this dataset generator using Node. So I'm going to start the terminal, go to the Node directory and type here Node dataset generator. You can put JS if you want, but it will work like this as well. And now those samples that are problematic should be omitted from our processing. Now, after this script is done, we also have to run feature extractor and this run evaluation if we want to use the viewer app, because it's based on the features and the decision boundary plot is calculated using that. So Node, feature extractor, and Node run evaluation. We're done, and you can see the accuracy is actually a little bit different, 42.36 compared to what we had previously. So now when we refresh this page, we will see these changing. Maybe here also some of these will look different, I don't know. And of course, some of these samples will not appear here. Let's see. Refresh. So a different result here as expected. And now the decision boundary plot is again pixelated. If you want to have a better one, then you have to wait and put there something like 5,000, or use the one that I provide for you in the resources here. There are two of them. One that you used previously is this KNN50, and the other one is KNN50 after filtering. And they look a little bit different, but not by much. So let's take this one, and in the data models, I'm going to paste it here, delete the small resolution one we just created, and rename this one so that I remove everything except for decision boundary. And refreshing now the page is going to show the other one that I gave you. It's much sharper now. Now if we scroll down, we see that some of these samples are missing. Sometimes entire users might be missing if I flagged all the samples. And I actually flagged all the samples of the flagged users, so those won't appear here anymore. And everything looks fine, but out of proportion. I would like to keep everything the same size here. So I'm going to fix that by going to Styles CSS, at our sample container, and I'm going to add here a max width of 8%. I noticed that this does the trick. So let's refresh, and now the things look better aligned. One more thing is that when we go here at our halfway point where the testing starts, you will notice Prophet here has his data split in two. Some of it will be the training data, and some of it is used for testing. That's just fine. It's where the midpoint happened to be. Now, one more thing I want to do is say somehow that we have this new flagging functionality. So I'm going to add at the title here an info button, and when we hover it, it's going to say some instructions how to use that. We do that in this viewer HTML file, and here in the h1 tag, let me just open it like this and type here span with a class called info button, let's close this span. And I'm going to add here this info button symbol. And then inside here, I will have a tooltip. Inside it, I will just write. Now let's save this and go inside our styles. At the bottom, one for the info button. Let's make it red and have the cursor be a pointer because we can click on it or hover it. And then when hovering, it's going to make the tooltip text visible. So one more style now for this tooltip text. And I'm gonna have this one have white text on a red background. I think the combination goes well. And let's position it so absolute positioning, hidden by default, and small font size. And let's have it round a bit and give it also padding and remove the bold of the font because that's how they are by default inside of this H1 tag. So refreshing. Here's now our button here. And when we hover it, we get the instructions.